analysis. Okay, so today we are going to discuss about here qualitative and quantitative analysis. Okay, qualitative and quantitative analysis. Qualitative and quantitative analysis. Okay, now in this one, let's see what is meant by the qualitative and quantitative analysis. First of all, we'll see what is meant the qualitative analysis. Qualitative analysis is nothing but it is the detection of the elements which are present in a given organic compound is called as a qualitative analysis. So what is meant by the qualitative analysis means here? Qualitative analysis is nothing but, first point, okay, qualitative is nothing but qualitative analysis is defined as the elements which are present in a detection of elements defined as it is the detection of the elements in a given organic compound. Okay, it is defined as the detection of elements present in a given organic compound. Okay, so what is meant by the qualitative analysis means qualitative analysis is nothing but it is the process or the detection of the elements present in a given organic compound. Actually, what are the elements present in a given organic compound? Which elements are there in an organic compound? Any one of you, Aditi or Tanish? What are the elements are present in a given organic compound? Organic compound is containing first carbon.
So carbon, hydrogen, oxygen, sulfur, halogens, nitrogen, and phosphorus.
Phosphorus and halogens. Very good, Aditi. Halogens can be represented with X. X is nothing but in this one either it may be fluorine, bromine, iodine. Okay, X is nothing but here halogens. What are the halogens means? Fluorine, chlorine, bromine, iodine. Any organic compound if we see means most of the organic compounds are they contains carbon as a more quantity. Carbon is the main element in a given organic compound. Along with the carbon, what are the other elements are present in a compound means either it may be hydrogen, oxygen, sulfur, nitrogen, phosphorus and halogens also it is present in a given organic compound. That we have to identify because of all compounds are not containing all these elements now. We have to identify the compounds contains which element. That process only we can call as a qualitative analysis. Okay, and what is the another one? It is the quantitative analysis process. What is meant by the quantitative? In name only it is there. Quantitative. So what is meant by the quantitative analysis means it is the process of estimation of the element. Estimation means every organic compound it contains particular amount of the carbon, particular amount of the oxygen, particular amount of the hydrogen, particular amount of the sulfur, phosphorus, nitrogen and other element. Okay, that particular amount only we can call as a quantitative. Quantity means it is the amount of the elements present in a given organic compound is called as a quantitative analysis. Quantitative analysis is going to be explain the quantity of the elements. Now you got the clarity all of you here. What is mean the qualitative analysis and what is mean the quantitative analysis? Qualitative analysis is nothing but detection of the elements in a given organic compound is called as a qualitative. Quantitative is nothing but how much quantity of the elements present in a given organic compound is called as a quantitative analysis. Now you got the clarity. Now in this one first we can check it out. Qualitative analysis. First we'll discuss about here qualitative analysis. Okay, first we are going to discuss about the qualitative analysis. Qualitative analysis. This part is finished means GOC is finished. Okay, so qualitative analysis. Sir, what is meant by the qualitative analysis? Qualitative analysis is already knows. Okay, and qualitative analysis. Detection of the elements is called as a qualitative analysis. In the detection process, we are using some chemical methods. By using some of the chemical methods, we can find out the elements present in a given organic compound is called as a qualitative analysis. Okay, in this one. First one. So detection of the carbon and hydrogen. Detection of carbon and hydrogen. What is the first one means here? Detection of carbon and hydrogen. First experiment. Detection of carbon and hydrogen. Detection of carbon and hydrogen. Okay, so that means identification set. Identification of carbon and hydrogen. If they had given some organic compound, we don't know the name. We don't know the name. Simply they had given some organic compound. Okay, then they're asking to identify the given organic compound is containing which elements means. So in this one we are doing some experiments. Sir. So what is the experiment we are doing? Is detection of the carbon and hydrogen. Sir, how we can detect the carbon and hydrogen means first whatever the organic compound they had given. Okay, organic compound. For the organic compound, if you add cuprous oxide, Cu2O, if you add here, sorry, cupric oxide, if you add as a cupric oxide, what is the molecular formula of the cupric oxide one? You can write as a Cu, okay, you can write as here CuO, this we can call as a cupric oxide, cupric oxide. Okay, so for the organic compound, if you add small amount of the cupric oxide and if we heat at high temperature, if we heat at high temperature means if the organic compound is contains carbon means then it is converted into the carbon dioxide. If the organic compound is containing, if the hydrogen means it converts into the water molecule. Both are exist in a gaseous form only. Both are exist in a gaseous form only. So same reaction I'll write in a separately. So for what we are taking here, first they had given us organic compound. For the organic compound, if we add cupric oxide and heat at high temperature, if the organic compound is containing carbon, if it is organic compound is containing the carbon means 2 moles of the cupric oxide is heated, added means it is converted into carbon dioxide plus 2 moles of the copper metal. Okay, and similarly, if the given organic compound is containing as a hydrogen, if it is containing the hydrogen means that it is heated with the cupric oxide. If it is heated with the cupric oxide means it converts into the water molecule plus and copper metal. Sir, how we can identify that the given compound is containing the carbon and hydrogen means whatever the carbon dioxide it is releases that we are passing through the lime water. What is mean by the lime water, Aditi? What is mean by the lime water? What is mean by lime water? Tanishk, what is mean by the lime water?
Sir, it's CaOH taken twice.
Okay, so it is correct only. CaOH taken twice. Calcium hydroxide, which is called as a lime water. So what are the carbon dioxide it is releases? That it is passes aqueous solution of the lime water. So lime water is nothing but calcium hydroxide. Lime water. Okay, so lime water is nothing but aqueous solution of the calcium hydroxide. So whenever you're passing carbon dioxide through the lime water, it turns into the milky white. How it is turns into the milky white? What is the milky white substance means here? Milky white substance is nothing but calcium carbonate. Okay, so whenever you pass the carbon dioxide, through the lime water means it turns into the milky white. It turns into the milky white. So whenever it turns into the milky white, so based on this one, we can say the given organic compound is containing carbon as an element. Okay, so the given organic compound is contain carbon as an element. Okay, that is the one test. And what is the another test? Here, it forms as a water vapor. Water vapor here, H2O, it is present in the gaseous form. What are the water vapor it is there? That it is passes through the anhydrous copper sulfate. Anhydrous copper sulfate. So what is the color of the copper sulfate actually? Do you know or not? All of you know or not? Can I show the
Sir,
color of the copper sulfate, ma? What is the color of the copper sulfate? All
blue
of you are done
color.
with that. Which color, ma? Sriveda?
Blue color.
Blue color, ma. Okay, aqueous solution of the copper sulfate. That means copper sulfate, it is in blue color. When it is in blue color means it is hydrated form. Okay, in hydrated form, it is in blue color. In anhydrous form, it is a colorless crystals. Copper sulfate is having here colorless crystals. It is colorless crystalline solid. So whenever you passes the steam through the anhydrous copper sulfate, immediately it turns into the blue color. Sir, how it turns into the blue color means it absorbs the water molecule. Whenever it absorbs the water molecule, it becomes as a CuSO4 5H2O. Hydrated copper sulfate, it always be appears in a blue color. Okay, hydrated copper sulfate, it turns into the blue color. So based on this one, we can say the given organic compound is containing the carbon and hydrogen as the elements now. Whether we can say or not. Okay, so based on these two experiments, we can say the given organic compound is containing carbon and hydrogen as elements. Okay, and other elements also it is there. What are the other elements are there in a given organic compound? Okay, what are the other elements are there in a given organic compound? Tanishq? Other excluding carbon and hydrogen means again we have a oxygen, nitrogen, sulfur, phosphorus, chlorine, bromine, iodine. So all these are the other elements are there. Sir, how we are going to be identify all these elements? Okay, so how we are going to be identify all these other elements means, sir, we can identify all other elements by doing Lassine test. Okay, so which experiment am I here? So by doing, we are going to find out the other elements. What is the name of the experiment we are doing? Means we are doing as a Lassine test. Sir, what is meant by the Lassine test? What is meant by the Lassine test means here, before doing the Lassine test, we had to prepare the Lassine extract. Okay, so what is meant by the Lassine extract? Any one of you know? All of you completed the practicals or not? How many members you completed the practicals? How many members you completed the practicals?
Sir, myself practicing over there.
Practicals are completed. You have done some salt analysis, Tanish?
Yes, sir. Yes, sir. Yes, sir.
Okay. Then what about the remaining? Aditi, Sriveda, Samhita, practicals are started or not?
So we have them in 12th grade.
Okay, Jan first week. Sriveda and Samhita.
It will be in February.
February. I'm not asking the final practicals. Are you practiced or not? At least have you seen the lab or not?
Lab is there, sir, but never went in.
Okay. Samhita, you?
So practicals are not done for us, sir. We're still doing.
Okay. Aditi, for you?
So we'll have it in next year. Like right now I'm in 11th.
Okay, now you are 11th. So next year they're going to be actually you are CBSE or state board?
So CBSE, sir, but they said they'll
CBSE
take
means
at once.
11th only they will start the practicals now. Okay, they won't start. Some institutions they won't start here. Okay.
Yeah, so like they said they'll do it once the 12th portion is completed.
Okay, okay. So, but here, so if you do the salt analysis and all means practical salt analysis and all, we are doing as a some lysine extract only. Okay. So by preparing the lysine extract, okay, how we can define how we can identify the nitrogen, sulfur, halogen, phosphorus, and all means first we have to do the lysine test. Okay. So we have to do as a lysine test. LA sodium extract also we can call as here. And that is also just LA lysine test LASSI GNE lysine test here. Okay, so lysine test. So by using the lysine test, we are going to be identify the other elements. Okay, what are the other elements we are going to be identify the lysine test means here? Nitrogen, sulfur, phosphorus, chlorine, bromine, iodine, and all we are going to do for the lysine test. So to do the lysine test, first we have to prepare as a lysine extract. Okay, lysine extract we have to prepare. I don't know, this method we can't use in laboratory. Actually, this method we can use in higher education sector. Okay, sir, what is mean by the lysine extract? Lysine extract also we can call as a sodium extract. Okay, this also we can call as here sodium extract. Sir, what is mean by the sodium extract and how you are preparing the sodium extract means here? Sodium extract. Okay, how we are going to prepare the lysine extract or sodium extract means first we are taking as a fusion tube. We are taking as a fusion tube. What is meant by the fusion tube? All of you have seen the fusion tube or not? All of you have seen the fusion tube or not, ma?
No, sir.
Okay, at least have you seen your pen refill?
Yeah.
Okay, so like that, however the pen refill it is there, like that we have some glass tube in laboratory. Okay, like pen refill only. So they have a small hole here. Okay, so that glass tubes are there. That only we can call it as a fusion tubes. Okay, so fusion tubes are both ends it is open, it is there. Fusion tubes are they having here both ends open. So how much length of the fusion tube it is required to us? We have to break it in. Okay, and if we heat at one corner means one corner is going to be closed here and another corner is going to be open. Okay, in from wherever the open corner it is there, through that one we are passing as the first organic compound. Okay, first what are the organic compound they had given that we are passing through the fusion tube. Okay, fusion tube how it will be there means here. Right, draw the small diagram. Okay, I don't know exactly. Slightly I'm getting set like this here. It is a small fusion tube here, and one end it is going to be closed. How we can close the one end is by heating at high temperature. Okay, by heating at one high temperature, we can close the fusion tube. In this one, we are taking as a sum of the organic compound. First, we are taking as a sum of the organic compound. After taking of the sum of the organic compound, we are placing some sodium metal. Okay, so we are placing as a some sodium metal. We are placing some sodium metal we are adding. Okay, so sodium metal is highly explosive with water. Which sodium metal we are adding means here dried sodium metal. Actually, sodium metal is stored in where we are storing as a sodium metal. Sodium metal is stored in kerosene. Where we are storing as a sodium metal means sodium metal is stored in a kerosene because it is highly reactive with the atmospheric air. At the same time, it is explosive with the water. So due to that reason, only sodium metal is stored in a kerosene. Okay, from that one we had to take as a small amount we had to take, and we are going to insert into the fusion tube. And if we heat this fusion tube until the red hot, okay, we are heating until red hot. If you heat until red hot, okay, red hot, okay, if we heat until to red hot, after heating the red hot, that means already you know stuff glass if you heat continuously means it is turning into the red color, you know or not? If the glass is heated continuously means the glass is turns into the red color. Until that we have to heat. Then only sodium metal is reacting with the organic compound. Okay. After heating that one, you have to place in a china dish. Okay. So china dish, a grinder it will be there. Generally we can call as a mortar. Okay. Mortar we can call. Mortar. Mortar means here it is made up of ceramics. It will be like this here. Okay, and it has a one grinder also, it will be there. One grinder it is there. Okay, in that one we are placing as a fusion tube. And if we crush this one, if we crush with this one with the hot condition only, it is completely converted into the powder. Okay, it is completely converted into the powder. After making of the finely divided powder, in this only we are adding as a distilled water. Which one we are adding here? We are adding as a distilled water. Okay, so all of you know what is the distilled water? Distilled water also we can call as a demineralized water. Distilled water also we can call as here demineralized water. In lab only we can use. For these experiments only we can use. Generally remaining time we can use as a tap water. Okay, if we add distilled water, means here sodium so distilled water means the substance is dissolved in a water. Okay, after dissolving in a water, that we are doing in a filtration. Okay, we are doing as a filter. If you filter that one means here the filtrate is called as a sodium extract. Okay, filtrate is called as a sodium extract. Sodium extract, that is only we can call as a lysine extract also we can call. Okay, whatever the filtrate we got, that we can call as a sodium extract. On filter paper we can observe the small gas particle. On filter paper we can observe some small glass particle. So by using this sodium extract, we are going to do some of the tests, the detection of the nitrogen, sulfur, phosphorus, chlorine, bromine, iodine, and et al. Okay, so now we'll go for the next step. Now we prepare the sodium extract or lysine extract. Next we are going to for here detection of sodium. First we'll write as here detection of the sodium. Detection of sodium. All this is the practical knowledge. So you know all of you. But JEE also practicals are very important. Sometimes they're asking the question based on the practical knowledge only here. Based on the practicals also sometimes they're asking the questions in the examination, JEE examination directly. Okay, now so we are going to detect about the nitrogen. So detection of nitrogen. Detection of nitrogen. Detection of nitrogen. Sir, how you are going to detect the nitrogen means? First, we are taking as a sodium extract. Okay, sodium extract. Sodium extract. In the sodium extract, if the compound is contains the nitrogen, actually nitrogen is present. Pure nitrogen it won't be there. So nitrogen it is combines with the carbon and it is combines with the sodium. Okay, so how it is present means it is present in the form of sodium cyanide. So nitrogen is present in the form of sodium cyanide. Okay, sulfur is present in the form of sodium sulfide in a lysine extract. In a lysine extract, nitrogen is present in the form of sodium cyanide and sulfur is present in the form of sodium sulfide. Okay, and halogens are it is present in the form of sodium chloride or sodium bromide or sodium iodide. They will be present in the form of here sodium chloride, sodium bromide, or sodium iodide. But nitrogen is present in the form of here sodium cyanide. For the sodium cyanide, so we are taking as a 1 ml of the sodium extract. How much ml we are taking, ma? We are taking 1 ml of the sodium extract. For that only, we are adding freshly prepared ferrous sulfate. We are adding as here freshly prepared ferrous sulfate. What is the molecular formula of the ferrous sulfate? FeSO4. Okay, if we add freshly prepared ferrous sulfate, whenever you add as a freshly prepared ferrous sulfate, the sodium cyanide is converted into FeCN. Ferrous cyanide is going to be converted and it forms as a Na2SO4. Okay, so this one is For this only we are adding as a Na2SO4. Okay, if you treat it with excess amount of the ferrous sulfate, if it is treated with the excess amount of the ferrous sulfate means, okay, if you treat it with the excess amount of the ferrous sulfate means 4 moles of the NaCN plus FeCN taken finds. It is converted into sodium ferrocyanide Na4 FeCN taken 6 times. It is converted into sodium hexacyanoferrate. Okay, it is converted into sodium hexacyanoferrate. For this only, we are adding small amount of the concentrated sulfuric acid. What we are adding, ma? So for this only, we are adding as a small amount of the concentrated sulfuric acid. So whenever you add as a concentrated sulfuric acid, okay, so concentrated sulfuric acid is, it converts the ferrous ions into ferric ions. Okay, whenever you add concentrated sulfuric acid means here in this one sulfuric acid is act as an oxidizing agent. Okay, this oxidizing agent is converts the ferrous ion. What is the oxidation state of the iron in ferrous sulfate? Oxidation state of the iron in a ferrous sulfate. Tanish, Aditi, Sriveda or Samhita.
+2, sir.
Very good, ma. So oxidation state of the iron in ferrous sulfate is here +2. Ferrous sulfate, ferrous ions are converted into ferric ion. So what is the oxidation state of the iron in ferric? So it is converted into
3.
+3 form. Okay, so +2 ions are converted into +3. So when the +2 ions are converted into the +3 form, by addition of the concentrated sulfuric acid. Concentrated sulfuric acid is converts the ferrous ions into ferric ions. Okay, that ferric ions are treated with the sodium metal. Okay, that ferric ions are treated with the sodium metal. That means how much moles we are taking means 3 moles of Ne4 FeCN taken 6 times. Na4 FeCN taken 6 times is treated with Fe4. Okay, Fe2SO4. Fe2SO4 taken 3 times. 2 moles of Fe2SO4 taken 3 times. If it is treated with the ferric sulfate, means it forms here Fe4 FeCN taken 6 times. FeCN taken 6 times, taken 3 times. Plus, what are the byproducts it is forming means? It forms as a 6 moles of sodium sulfate, Na2SO4. It forms as a Na2SO4. What are the Fe4? FeCN taken 6 times it is there. It appears as a Prussian blue color. Okay, it appears in here, Prussian blue color. So whenever you get as a Prussian blue color, that indicates the presence of the nitrogen. Okay, so whenever you will get Prussian blue color means that indicates the presence of the nitrogen. Okay, based on this one, sometimes they're asking the question also. What is the question they're asking means here? What is the IUPAC name of the Prussian blue color? What is IUPAC name of the Prussian blue color? So all these concepts are you will get at coordination compounds. In 12th we have a complex compounds, coordination compounds it is there. You know, there you will get IUPAC complex, IUPAC nomenclature of the complex. Sir, what is the IUPAC nomenclature of the compound means here? Iron 3 hexacyanoferrate. Hexacyanoferrate 2. So this is the previous question. That is previous question here. Okay. What is the IUPAC name of the Prussian blue color precipitate? So what is the IUPAC name of the Prussian blue color precipitate means here? Iron 3 hexacyanoferrate. Okay, so this also we can call as a ferrocyanide also we can call. Okay, ferrocyanide also we can call. But IUPAC name means iron 3. In this one, 3 is nothing but oxidation state of the iron. Okay, so what are the oxidation numbers we are writing in a closed brackets? The remaining are the IUPAC name. Now you got the clarity. So whenever you got as a Prussian blue color precipitate means that indicates the presence of nitrogen. Okay, so now you got the clarity. All of you have any doubts here? No, na? Next, we'll go for another test. So detection of the sulfur. How we are going to identify the sulfur in a given organic compound? The second one is here. Detection of the sulfur. Detection of sulfur. Detection of sulfur. But how we are going to identify the sulfur in a given organic compound? Okay, so we have a different test. Okay, we have a different test. Sir, how we are going to identify the sulfur? Actually, sulfur in lesson extract. Sulfur is present in the form of sodium sulfide. Okay, you are taking as a 1 ml of the lesson extract. For the 1 ml of the lesson extract, if you add aqueous solution of lead acetate, PbCH3, COO, okay, so COO. So if you take aqueous solution of the lead acetate, so for the sodium extract, if you add aqueous solution of the lead acetate, if you add aqueous solution of the lead acetate means it forms lead sulfide, PbS. It forms as a lead sulfide and it forms 2 moles of the CH3 COONA. Whatever the lead sulfide it is, that it appears as a black color precipitate. Which color precipitate you will get as a black color precipitate? If you got as a black color precipitate means that indicates the presence of the sulfur. That indicates the presence of the sulfur. Okay, so we have another test for the sulfur. What is the another test for the sulfur we are having means here? Test with sodium nitrochloride. Test with sodium nitrochloride. Sodium nitrochloride. So what is the molecular formula of the sodium nitrochloride means? We are taking as a lysine extract. Lysine extract is containing the sodium sulfide. For that one, we are adding as a aqueous solution of the sodium nitrochloride. What is the molecular formula of the sodium nitrochloride means? Na2 FeCN taken 5 times NO. So this we can call as a sodium nitrochloride. So when the lysine extract is treated with the aqueous solution of the sodium nitrochloride means it gives us a violet color precipitate. Okay, which color precipitate you will get, ma? You will get as a violet color precipitate. So whenever you will get as a violet color precipitate, that indicates the presence of the sulfur. Okay, so what is the molecular formula of the violet color complex means here? Na4 FeCN taken 5 times NOS. So this it appears in the form of here violet color. So this it appears in the form of here violet color. If you got violet color means here that indicates the presence of the sulfur also. Okay, and one more test also it is there. One more test. What is the another test we are having in the detection of the sulfur means? Generally, sulfur is present in the form of in the pure form, in the form of sodium sulfide. At the same time, sulfur also it is present in the form of sodium thiocyanate, NSCN. This we can call as a sodium thiocyanide. Thiocyanide. Okay. So when the sodium thiocyanide is treated with, that means the lysine extract is treated with neutral FeCl3. Neutral FeCl3. If it is treated with the neutral FeCl3 means you will get as a blood red color precipitate. Which color precipitate you will get, ma? You will get as a blood red color precipitate you will get. So how the blood it will be there? What is the color of the blood? that kind of the precipitate you will get. So that's why I'm asking means here, all is the practical based question. If you have done some experiment means you will get some idea. Okay, for that reason only I'm explaining clearly. So which type of color you will get, sir? If you got as a red color precipitate, blood red color precipitate means that indicates the presence of sulfur in a given organic compound. Okay, so until here clear? All of you understand here?